Hello everyone, and once again welcome to another episode of these video tutorials that we've been doing now. And I just noticed that the last video that we did on connecting buttons to Atmega32 microcontroller, I overlooked. There is a very important part, a key part that I overlooked, and that was an importance of using functions in a microcontroller, in our codes or in our firmware. And I'm just going to consider the last project that we did. And what you are looking at on your screen right now is actually the schematic that we had, and you're also able to notice that I've added another switch, switch 5 SW5. Now to our firmware, it's still intact. It's the last code that we did. And let me just take you to while one loop and consider this, everything inside while one loop. It's always important to keep while one loop less populated as you can. And if you look at it very well, it's highly populated and it's not tedious. So I'm going to say that everything that we did here, we can make it simple and tidy and organized if we could use a function. And today I'm going to introduce a function that will do this for us, and we are going to make it organized and depopulate while one loop. So we can do this by declare or defining another function. So I'm just going to function prototype. These are called function prototypes. Like this one we have here, this is a function prototype. I'm just going to define another one and call it LED blink. Obviously, we are not going to be returning anything from that function. Let me just name it LED blink function. You can choose any name for your functions once you get to work with functions like I'm doing right now. And I want to pass a value inside the function int-8. That's not it done. Let me just name this as m. We have a variable inside our function, and that is letter m. So with our function, what we are going to do, okay, let's do this. Let's have some lines of code inside our function. Control C for copy, Control V for pasting. Once again, I'm going to declare another variable inside our function. 98-t. This is how to declare an 8-bit integer value. An 8-bit integer value. We have these are a variable of data type, integer data type, but it is an 8-bit integer data type and it is unsigned. So it's not a negative number. That's what unsigned means, and it's an integer value of this. We always use this when we want to save on our memory, because instead of declaring it as int, which is a 16-bit number, which will take up more space than what we have here, unsigned integer variable of 8-bit. So let's just call this, let me just name it value. So here we'll be passing the switches that we have connected to our microcontroller actually are giving values. Like The first switch will always tell the microcontroller to blink the LED twice. So what I'm going to do here is whenever this function is going to blink LED corresponding with the switch that has been pushed. So I'm just going to employ a for loop here for shift. Let me just equate this to M. Actually, I also need another variable. 8 y. This is why we are going to use it as a control. This variable y, I'm going to use it as a control variable in our for loop, like we used I the last time we did it. Y should always be less than. Okay, y should always be less than value. A variable value is equated to variable m. The variable, this function, it takes in one variable, one parameter or one argument, which is m, and then we are going to use that same variable or same argument that is taken in by our function. We are going to use it here, and this is how it's used. We'll store that variable in another variable called value, and which we are using to control. We are using it to control our for loop. Y. Then this is where we blink our LED. I'm just going to copy paste what we had here. Control C. Okay. Control V. It's ugly. Let me just do something. What happened? This is the price that we have to pay with copy pasting. But we can afford it. That's the beauty of it. Shift tab, shift tab. And okay, I noticed that 1 second is actually 2 minutes. Let me just change this to 500 millisecond. And actually our function is done with. Just how our function works, it takes in an argument or a parameter, then it's stored in, it's taking in an argument or a variable, then the value of that variable is stored in another variable over here. Then we've also declared a control variable y that we are going to use to control our for loop. So when this function is called, void LED blink, a variable is passed. It takes in a variable, we are going to see how now this function is going to be called in our while loop, or in our while one loop. And now I'm just going straight to our while one loop, and I'm going to do away with some part of these codes like this one. I'm also going to do away with this. I also have to do away with this one. Do away with this one. And leave the else as it is. Now, for the first part, if button pressed pin A0, we are going to call that function. Let me just copy paste our function. Where is it? Control C for copy. Control V for pasting. Similarly, Control V, Control V, Control V for pasting. This is what. So whenever we push a button, this function is called, and we have to pass. We have to. It's taking in a value. So pin A0 was actually supposed to blink our LED twice. So we are just going to. Our function is going to take this one 4. Then this one was supposed to blink it 6 times, and then the last one will blink it 8 times. And now you can let me take this. I'm just going to make it as tidy as possible. And now you can see how organized our while one loop is, how depopulated it has become, because before it was actually really populated and disorganized. So okay, that should be for us. So another thing that I just did here was to add another button. I'm going to show you another function of buttons that I skipped, but I think you should actually know. Let me just put this one here. I'm going to use that switch 5 to. Its function will be to toggle our LED on and off. That means if I push it when it was off, it becomes on. If I push it when it was on, it turns off. Just like our household switches. When your light bulb was off, you push on the switch, it is turned on, and vice versa. So that's what we are going to do with our switch 5. Now to do that, it's first I've connected it to. I'm connecting it to pin C0, so I have to make that one as input as well. Pin C0, we have to make it as input. I'm just going to copy paste this one. Control C, Control V, and pin C0. It's that simple. By default, it's always the status is always low, but let me just to be sure, pin C0. So that's done. Control C. Control V. And now let's introduce this if. Okay. What am I doing actually? Control, let me just do it down here and have this on. Control C for copy. Control V. Okay, now as it is now, this line of code will just write a 1 on the pin, which is 5 volts. But we want, whenever we push it, it toggles on and off. So we are just going to delete that and add this on. Now this part, if it was off, it will be on, and it will, and if we push it when it was off, it's turned on. If we push it when it was off, it's going to be turned on. So let's just build our code. We can save and build our code. Let's see if it compiles successfully. We are going to run our simulation. Okay, so we have our self-warning unused variable I because we did away with the for loop. We can just comment it out, save, and then our code can run with warnings, but maybe it might never run properly. So, but the warning that we had, it was a warning that was not going to harm our code. So it is built and compiled successfully. Let's go ahead and run our code. So first I'll demonstrate the function of switch 5 that we introduced, and it's not working properly. That means something is wrong. How about the rest? So our function is actually doing everything that the other code was doing. All we've done is to make it tedious our while one loop. Now everything is working the way it was working before. What is not working is the switch that we just introduced, and we are going to investigate why it isn't. So just going to stop it and yeah. Now, okay, look at it. And the issue that we have is over here, value 7. We forgot to change it to 0. So let's save our code, build, and then run. So when it's off, it should be on. Yeah, we're still having some issues. So let's just go back to our code and see where the problem lies. Now we are going to see where our codes have why it's not going to work as intended, because we want to toggle LED on pin B0 on and off, and you see everything has compiled successfully, but it's not working the way it's intended to. So as I said before, with this, it's allowed. It's very okay to make mistakes, because that's how we learn. With every mistake we make, we are always going to learn from it. And now looking at our code, let's look at this line, because it's the last line that we introduced. From here, button pressed pin C, port C, pin C0, that is correct. Then we are supposed to toggle an LED on and off that is connected to port, actually it's connected to port B, pin B0. So this is where we have issues. We are having issues. It should be port B, and then it should be pin B0. So just change it. We are just going to change that and save our project. Then build, and let's run and see if it works. So toggling means when it's on, it's going to be off with when we push button switch 5, and when it was off, it should turn on. Like now it's off. If I push it, it turns on. If I push it, it's off. I push it, it turns off. I push it, it turns on. So that's what toggling means, and this is always a very important area concept in when running or working with microcontrollers, and eventually it has worked successfully. And the function that we introduced over here to depopulate our main function or our while one loop has also worked correctly. And this is what's amazing when it comes to working with functions. They are always going to make your code organized and easy to work with and easy to navigate. So like navigating this code becomes very easy, because it's been you can see the arrangement in while one loop as opposed to before. Can even it even becomes better when I do this. I just squeeze this. Like before, we had we were using for loop, and we had 4 of them inside our while one loop, and that was making our while one loop inside our while one loop populated and disorganized. So now we are on. Now what we do, we just get to do a function call and pass a variable into it, and this is how functions work. I know by now, for those who are acquainted to coding in C or C++, or maybe I'm going to say that if you got your way to such kind of video tutorial channel like this one of mine, then I might as well say that you have an idea of how C and C++ programming works, and to some extent I can confidently say that for some reason you have encountered or worked with functions, and you are able to understand and appreciate what we've done here with our function calls. and function definition, and how we've applied functions to make our code look tedious and more organized than when we choose not to use function. Reasons are obviously going to be known to us, but it's going to be important to apply or employ functions in our code so that it becomes easy to navigate and to work with. I think that's it for now. And just to enjoy what we've done, just to confirm that it's working like it worked before. If I use switch 1, it will blink it twice, and the second switch will blink it 4 times. Then the third switch will blink it 6 times. And the last switch 8 times. 2, 3, 4, 5, 6, 7, 8. And this one will toggle our LED on and off. And that's it for importance of functions. If you have any questions regarding this, you can always in our comment section. I'm available to take any question, and we are going to support each other. Thank you for choosing Atmega32, and until next time when we'll be doing interrupts, bye bye for now.